Good morning, boys and girls, and welcome to grade 9 mathematics. Term 2, we are dealing with geometry of 2D shapes. So basically today we are going to start with grade 8 revision, types of triangle. Behind me I've drawn different types of triangle. So we're just going to take it easy and start with the first one. The first one will be this one on my top left. Okay? Looking at this triangle, obviously it has got we call it triangle ABC. So mathematically, we use the notation triangle ABC. Okay, this kind of a triangle, looking at it, it has got different sizes of the sides. Looking at side AB, it has got one line. Side BC, it has got two lines. And then side AC, it has got three lines. The lines that I'm talking about are this small strokes indicated here. So this kind of a notation mathematically, it indicates that all the sides are unequal. And then this type of a triangle that has got unequal sides, we call it a scalene. All sides are not equal. It's a scalene triangle. That will be triangle number 1, and we move on swiftly to the second triangle. Looking at the second triangle, we call it triangle DEF. You call it triangle DEF. One can call it triangle EFD or DFE, however you want to call it, as long as all the letters are there in on your notation of triangle DEF. Okay, so looking at this triangle, we have got two sides that are equal. How do I know that the sides are equal? There are two strokes on this side. I've got one stroke this side and one stroke that side. That indicate that side DE is equals to side DF. And then at the base there, I have got angle E, which is equals to angle F. How do I know? They've indicated with these dots there that these angles are equal. And this is a lesson that we have to learn today, that this angle EF, angle E rather, is equals to angle F. Why are they equal? Because they are opposite equal sides. If you can see, if you can check this triangle, side DF is equals to side DE. So we conclude that angle E is equals to angle F, simply because they are simply because opposite angles of equal sides. I hope that makes sense. They are equal because they are opposite equal sides. Looking at these areas. And then what is the name of this triangle that has got two equal sides and two equal angles there? We call this an isosceles. An isosceles triangle. Isosceles triangle. I hope that all the facts are understood there. Okay, and then we go to the third one. This third triangle there, looking at it, I can see that I've got sides that are equal. All three sides are equal. And inside, I see the angles that are measured to be 60 degrees. And then they are all equal. So this kind of a triangle, we call it an equilateral triangle. So triangle GHI is an equilateral triangle simply because all sides are equal and all angles are equal. And we are moving to the fourth triangle, which is triangle JKL. JKL. So this triangle, looking at it, I do not see any sides that are equal. There is no indication of sides that are equal. But inside, I can see angles. Angle 50, angle 60, and angle 70. These angles are telling me something. All these angles are acute angles. Acute angles, we're talking about angles that are just above 0 but less than 90. So we call this triangle an acute angled triangle simply because all the angles inside are acute angles. So we say it's an acute angled triangle. Yes, that's all about it from this side. Let us move on to this other side. We have got two more triangles to talk about. Looking at this one, I think this is the famous triangle in mathematics. The first thing that I noticed there, I see a small square there that normally tells us that the angle here is 90 degrees. So we call this triangle a right angled triangle. All right, and then what we have to know, we normally use this right angle triangle in theory to prove theorem of Pythagoras. Theorem of Pythagoras basically proves that adjacent squared added to opposite squared gives us a hypotenuse squared. So let me just say that again. This is adjacent. This is adjacent side. Adjacent. And this is an opposite side. And this is hypotenuse. We're experiencing some spelling problems there. If somebody can help me with the spelling of hypotenuse. Hypotenuse. There, so this is our right angle triangle, and then we normally in theorem of Pythagoras we have adjacent squared plus the opposite squared. I'll just write O, opposite squared is equals to the hypotenuse squared. So if you want to find the side of hypotenuse, basically it is hypotenuse is equals to a squared plus O squared. By the way, I'm using O because I said this is opposite side, all into the square root. So that's a theorem of Pythagoras. But anyway, what I wanted you to know is that it is the right angled triangle. So now we're moving on to the very last triangle for the day, which also does not have equal sides. There's no indication of equal sides or whatsoever. But then we are talking about, we see the angles inside the triangle. So we are seeing that we've got two acute angles and one obtuse angle. And this fact then help us to conclude that this is an obtuse angled triangle. I hope all this made sense. Just a quick review. We have got a scalene which has got three different unequal sides. All sides are not equal. And then we have got isosceles, which has got angles that are equal, two angles that are equal and opposite sides that are equal. And remember guys, when we prove these angles that are equal with isosceles, we are saying these base angles are equal because they are opposite equal sides. Hence I wrote opposite angles of equal sides. And then we go to equilateral triangle. Well, all sides are equal and all angles are equal. And we have got an acute angles. that we know it by the angles. In all angles are acute angles, and we have got a right angle triangle. We know it because that is a 90 degrees there, and we've got an obtuse angle triangle, which it has got one obtuse angle. Obtuse angle is just an angle just above 90 but less than 180, and then of course it has got two acute angles, but the fact that it has got an obtuse angle is the one that makes us to call it an obtuse angle. Just one last thing before we go for the day, I just want to show you something regarding the properties of a triangle. There are 1, 2, 3 angles. We've got 1, 2, 3 angles that have got sizes of angles inside. So I just want us to observe something. I just want us to add all those angles and see what will be the sum of all interior angles. We're going to start with equilateral triangle. We're going to add all angles inside the triangle. So we're going to say 60 degrees plus 60 plus 60. And then we want to see how much will it give us. I want you to note something, boys and girls. I wrote 60 degrees here, and here I wrote 60. So when you wrote 60 like that, you are not talking about angles, you're talking about something else. So it is always important that you write your degrees there. So 60 plus 60 plus 60, it gives us 180. So we are learning here that interior angles of a triangle add up to 180. So let's see, is it an issue of equilateral triangle, or is it going to be every triangle adding to 180? So let's check this one, which we said is an acute angle triangle. So we have 70 degrees plus 50 degrees plus 60 degrees. Let's see how much do they add up to. 7 plus 5 is 12. 12 plus 6 is 18. Okay, they add up to 180 degrees. So we can make a conclusion that sum of interior angles add up to 180. So before we make that conclusion, let's go and check quickly with an obtuse angle triangle if whether they will add up to 180. So we have got 40 degrees plus 100 I don't have enough space here, so I'll just say 120 degrees plus 40 degrees plus 20 degrees, and then let's see, 0, 2, 4, 6, 8, 180. So basically it is true that sum of interior angles of a triangle add up to 180. So remember guys, this is the type of math that when you write it or solve it, you have to give us a reason. So the reason for this angles adding is sum of interior angles of a triangle add up to 180. You don't really have to say add up to 180 because already you have showed us that they add up to 180. So your reason will be sum of interior angles of a triangle. Okay, let me just write a full angle there of a triangle. Yes, I think this will be it. The next time we meet, we'll be talking about congruency and similarity.